conference. We really appreciate you being here. I'm Dr. Frank Cole. I have the real pleasure of being the director of the Gemstone program and also a professor of environmental science and technology here at the university. We're here to celebrate what these students have accomplished in the last 4 years. It's a tremendous amount of blood, sweat, and tears, I can guarantee. It's gone into each one of these team products. And they have a tremendous product to share with you. So what we're going to do is go ahead and let them present their presentation for about 25 minutes. And then we're going to give our distinguished panel discussants up here, experts in the field, who are going to be as kind to them as they wish to be, with some questions for about 10 minutes. And then we're going to open up the audience for about 6 or 7 minutes of questions. And then our students will lead with the discussants to a secret padded room down the hall. We'll spend about an hour really dissecting what they've done for the last 3 years. So they're going to get a lot of good, solid feedback. So that's how we're going to operate this. Get the team ready to go. Let's go.
Good afternoon, everyone. We are Team ADDICT, analyzing delay discounting through impulse control training. My name is Chinisha Srivastava, and I will be presenting today with Louis Wolf, Jennifer Rodenberg, Sheer Rogier, Spencer Elias, and David Tunnell. The general societal problem is that each year, 23.2 million Americans seek treatment for substance addictions. In the U.S., there are a large number of drug prevention programs, which collectively spend millions of dollars attempting to combat substance abuse, primarily through rehabilitation programs. However, some 40 to 60% of addicts relapse, and of course, this statistic only applies to those who even seek help in the first place. These statistics show how crippling of a societal issue addiction is, and how it needs to become a top priority in research. Addiction not only affects the individual, but affects society as a whole. According to the National Institute of Drug Abuse, the total cost of addiction in America is estimated to be over $5 billion. Substance abuse also has the potential to affect the occurrence of crimes. The U.S. Department of Justice finds that over 50% of individuals who have been convicted for violent crimes were under the influence of alcohol, and over 10% of individuals who were implicated for homicide were under the influence of some type of drug during the occurrence of the crime. Our team chose to address this issue because of its strong potential to make positive changes in our society. As mentioned before, the high relapse rate, which is at least 50% based on only conservative estimates, is indicative of our poor understanding of effective treatments for addiction. It also questions if toxicity is the only cause of drug addiction. We also believe that addiction is not an isolated behavior. Rather, it arises from personality traits and tendencies, specifically impulsivity. We have chosen to study addiction through the lens of impulsivity. We also have chosen to focus on the behavioral aspect of the drug, rather than the toxicity of the drug, which I will explain in the further slides. The formal definition of impulsivity is the tendency to act on a whim, and in doing so, disregard a more rational, long-term strategy for success. Impulsivity and addiction have a complex relationship with one another, and this has been the subject of much research and controversy. It is believed to play a role in a number of maladaptive behaviors and is heavily intertwined with measures of individual self-control. In our study, we have chosen to explore the relationship between these two variables. To give more insight on how we are focusing on the behavioral aspect of the drug, rather than the toxicity of the drug, we present to you the following situation. Imagine the lifestyle of a heroin addict and the lifestyle of a gemstone student. Every time the addict shoots up heroin, he's getting an immediate reward, which is the high of the drug. On the other hand, the gemstone student, she has been studying for days, maybe even weeks, to get her reward, which is a satisfying A on her final. These patterns of behaviors have a significant difference. The heroin addict gets a reward every time he performs a behavior. The gemstone student, on the other hand, gets a reward after behavior over a long extended period of time. So ultimately, we are asking, is an addict a more impulsive person as a result of being rewarded every time he abuses the drug? Reinforcement schedules model these two different behavioral patterns we have discussed with the student and the heroin addict scenario. It refers to how a person gets rewarded for performing a certain behavior. In our analogy, the heroin addict was getting rewarded on a fixed ratio 1 schedule, meaning that he was getting a reward every time that he did his behavior, which was shooting up the heroin. The student, on the other hand, was getting rewarded on a fixed ratio n schedule, meaning that she had to perform her behavior multiple times before she got her reward, which was getting the A on the final. In our study, we have chosen n to be 10, which means that a reward will be administered for every 10 behaviors. We will also be measuring impulsivity through delayed discounting, which will be explained further in this presentation. I would now like to introduce Lewis to discuss about the literature review and the hypothesis.
Thank you, Drisha. All right, so existing research looks into the root cause of drug addiction and its basic processes, and it's definitively shown that impulsivity can lead to different forms of addiction. There are a few studies I'd like to highlight from our literature review, mostly which deal with correlation between addiction and impulsivity. So Dr. Walter Michel's lab at Stanford conducted a study in which they measured the impulsivity in young children ages 4 to 6 and tracked them through adolescence and adulthood. The children were offered a snack in an unsupervised room and told that if they waited 15 minutes, they could have 2 of the snack, while if they ate it in that 15 minutes, then they wouldn't. Impulsive children, those that weren't able to wait the 15 minutes to eat the snack, had significantly worse outcomes down the line in terms of SAT score, educational attainments, and other measures. Other studies deal with cigarette smoking or higher rates of alcohol intoxication from social drinkers. In particular, one 1999 study by Dr. Suzanne Mitchell showed that smokers who tended to show smaller, more immediate rewards and preference for larger delayed ones as compared to the non-smoking group, again signifying higher levels of impulsivity in smokers. In human adolescents being treated for marijuana use, delayed discounting was measured to predict treatment outcome. Participants completed a delayed discounting task before behavioral treatment, and those with higher levels of delayed discounting responded worse to treatment outcomes. This was a Stanger study in 2012. Another study by Jennifer Perry showed that impulsivity can predict cocaine self-administration in animal models. Female rats were allowed to, were tested in high and low impulsive groups by allowing them to select smaller, more immediate food rewards or larger deferred outcomes as a measure of their levels of delayed discounting. Later, these rats were allowed to self-administer cocaine, after which a greater percentage of rats in the high impulsive group required self-administration and did so at a rate significantly faster than those in the low impulsive group. Subsequent investigation revealed a similar effect in male rats, reinforcing the delayed discounting model of impulsivity as a predictor of subsequent behavior. So all of these studies showed a clear link, one between pre-existing levels of impulsivity and subsequent variability to vulnerability to drug addiction. However, there's a gap in our understanding. We don't know if addiction itself can cause impulsivity, and this lack of information has been the root of our problem. There's current literature that causally links reinforcement schedules in humans to increased impulsivity levels. Our study does this using delayed discounting to quantify impulsivity. Again, that's the deferred rewards and discounting how much you value them. Our research is novel because it uses human participants and it makes our research more applicable in a clinical sense. And we're focusing on the behavioral aspect of addiction as opposed to the toxicity of the drugs. So to summarize what we're really focusing on, here's a depiction of the relationship we're exploring. As you can see on the left, previous research has established a causal link from impulsivity to drug use. And an impulsive person is more likely to engage in drugs. But the relationship on the right is still uncertain. We're asking, is it true that the act of administering drugs can increase a user's impulsivity? And if this is the case, we can see how it models of drug addiction as a vicious cycle that needs to be broken in treatment. So, as I mentioned before, our research question was, does the reinforcement schedule of drug use cause increased impulsivity? From the knowledge we gained learning about the subject, our team predicted that participants under the FR1 schedule, that's people that were reinforced every time they committed a behavior, would exhibit an increase in impulsivity, while those participants reinforced under an FR10 schedule would exhibit a decrease in impulsivity. We further hypothesized that the control group would remain stagnant and the same throughout the study. I would now like to pass it on to Jennifer to talk about our methodology.
Thanks, Lois. Our experimental design consisted of a 3x2x2 mixed design. The between subject variables included our three groups, FR1, FR10, and our no training control. The within subject variables included the 2 reward sizes and our 2 assessments. We recruited college students at the University of Maryland through the UMD SONA system and by word of mouth. Participants ranged in age from 18 to 26 with a mean age of 20.5. In total, we had 69 participants, 28 male and 41 female. Our methodology is illustrated in this flowchart. All participants took a pretest and then were placed in one of 3 groups, and after which they were taken through their training and completed a post-test. The pretest was administered before the participants knew what group they'd be a part of. It consisted of the consent form, a demographic questionnaire, BIS and ISING self-report tests that characterize personality, and a delayed discounting test that quantifies impulsivity. The pretest, as I said before, was administered before the subjects knew what group they were in. Once they were placed in the groups, they began their respective training. The first group was FR1, fixed ratio 1. This is the group we used to model regular drug use. After taking the pretest, the FR1 group immediately began training with a visual attention task that I'm going to describe later. The training consisted of 10 30-minute sessions over a 2-week period. After the 10th training session, the post-test was immediately administered. The second group was FR10, fixed ratio 10. This is the group that we used to model non-drug-like behavior. They also completed 10 training sessions over the course of 2 weeks, after which they were immediately administered a post-test. Finally, we have our control group. After the pretest was administered, the participants waited 2 weeks to take a post-test without completing any training. This was done in order for us to determine the effect of time alone would have on the difference between the pretest and the post-test, in order to control for this variable. By having a control group with no training, we were able to see the effects of just the training. After the training, all the groups took the same post-test, which was consisted of a delayed discounting test. So the clip you're about to see is an excerpt of our task. As you saw, combinations of 4 letters appeared on the screen. Participants were asked to click the X every time it appeared. For the participants assigned to the FR1 group, they were rewarded 5 cents every time they correctly clicked the X. For participants in the FR10 group, they were rewarded 50 cents every 10 times they clicked the X. Despite the differences in reinforcement, overall earnings were the same, around $20 each session. The only difference for the 2 training was the schedule on which they were rewarded. The participants received both auditory and visual stimulation when they received their reward, through the money that you can see on the right, and also the ding that they heard every time they correctly clicked the X. The study was, the visual attention test, was administered on a secure computer in the Paper laboratories, and goggles were used by the participants in order to control for the visual field to block out outside stimuli. In addition, it's created a unique environment so that visual stimulus that were applied during our visual attention task were now carried over to the outside world for our viewing participants. As I said before, we quantified delay discounting using, we quantified impulsivity using our delay discounting task by measuring the difference point. An example, say I was to offer you $200 now or $1,000 in a month. Most people are going to say that they would wait for the $1,000 in a month. What if it was $500 now? You'd probably still wait the month for the $1,000. If it was $990 now or $1,000 in a month, most people are going to accept the $990 now instead of waiting a month for another $10. The point at which you're equally willing to accept the money now or later is called the indifference point, and using that number, we're able to quantify impulsivity. A person who's willing to accept $300 is considered more impulsive than a person who will accept $700 because they're less willing to wait for the award. In our study, we expected that our FR1 condition, the blue line, would show a decrease in their indifference point, which would indicate an increase in their impulsivity levels. We expected our FR10 situation to show an increase in their indifference point, which would indicate a decrease in their impulsivity levels. Finally, Finally, we expected our control group to show no change in their indifference point, which would indicate no change in impulsivity. I'd now like to introduce Spencer to discuss our results.
Thank you, Ben. So the indifference points were calculated for several different time delays, 1 month, 6 month, 1 year, and 5 year periods. In order to combine these into a single measure of delay discounting, we plotted them on this graph. This graph has delay in days on the horizontal axis and the difference point on the vertical axis. We have two hypothetical participants here, one of which has high impulsivity and one of which has low impulsivity. The high impulsivity participant has lower indifference points and therefore more impulsivity. The participant with low impulsivity has higher indifference points. We can then connect these points with straight lines to create a curve that represents the decreasing value of the reward over time for the participants. And then calculate the area under this curve to quantify all these indifference points together into a single measure of impulsivity. That can be done by breaking trapezoidal segments and then summing those segments. Before proceeding to our main analysis, we tested all groups for any pre-existing differences on the variables that we collected in the pre-assessment. For all qualitative demographic variables such as ethnicity and gender, we used a Pearson chi-square test with an alpha level of 0.05. And this table shows the results of that analysis. All the values were greater than 0.05, so no significant difference among groups on any of these variables. For all of the quantitative demographics variables, such as age and GPA, we used a one-way minimum by groups to test for pre-existing differences with an alpha level of 0.05. And again, we found no significant differences, all the values were greater than 0.05. And finally, we performed a one-way minimum by group for the self-report measures of impulsivity, which are the EIS and the ISINC questionnaires, and we continue to find no significant differences among the groups. This means that we found no significant differences in the distribution of groups for any of our pre-assessment variables. And with no pre-existing differences, we proceed to our main analysis. The main analysis is a 3x2x2 mixed design analysis of variance with reward size and pre- and post-assessment changes as removed factors, and group assignment as a between groups factor. We set the alpha level to 0.5 for all tests involved in the unit. One clear main effect that we found was the size of the reward. We calculated indifference points using reward sizes of $50 and $1,000, and the graph displayed demonstrates the main effect of the reward size. In the $50 condition in blue on the left, there were lower values of AUC than the $1,000 condition on the right side in red. Bars represent standard error. This result was statistically significant in less than 0.05. And this effect is well established in the field and gives us greater confidence in the validity of our results. There were no interactions of this effect with either group assignment or with pre- and post-assessment changes. This next graph shows pre- and post-assessment changes for each training condition. Each data point represents the mean AUC for that group on that assessment, and the error bar represents the other error. We did find a significant interaction effect. Specifically, our simple effects tests revealed that the FR1 and FR10 groups in red and blue at the top had no significant change from pre-assessment to post-assessment, and the no training control task is on the bottom in green, had significantly higher values of AUC on the post-assessment compared to the pre-assessment. Now I'd like to introduce Sheer to present our interpretation of the results.
Thank you, Spencer. As can be seen in this graph previously introduced by Spencer, there was no change in impulsivity in the FR1 and FR10 groups, but a decrease in impulsivity in the control group. However, taking the control group as the only group that received no training throughout the duration of the 2 weeks, we will use this group as a baseline for further data interpretation. This means that we will assume that the increasing AUC of the control group was due to factors outside of the training condition and can be assumed to have affected all participant groups. With that being said, we normalized our data among all 3 groups to reflect changes in AUC relative to the control group remaining unchanged. This figure shows the baseline control group and the changes in the FR1 and FR10 relative to the control.
Based on this figure, we can now conclude that participants in both the FR1 and FR10 groups became more impulsive as their indifference points decreased from the pre- and post-test assessments relative to the control. The behavior exhibited by the FR1 group is consistent with our hypothesis. However, in our hypothetical model, we expected participants in the FR10 group to decrease in impulsivity, as their training condition was supposed to represent a non-drug-like reinforcement schedule. Based on our results, however, we can conclude that FR1 and FR10 may have been too similar. Participants in the FR1 reinforcement schedule were rewarded for every correct response, which occurred approximately every 3 seconds. On the other hand, participants in the FR10 reinforcement schedule were rewarded for every 10 correct responses, which occurred approximately every 30 seconds. This time delay suggests that both training groups mirror a drug-like reinforcement schedule, as a non-drug-like reinforcement schedule would likely occur on the scale of weeks, not seconds or minutes. There were several limitations in our study that should be addressed. First of all of our study participants were University of Maryland students between the ages of 18 to 25 years old. Such a sample demographic cannot be generalized for a larger population. Second, participants in the no training group were compensated in a different manner and amount than participants in the FR1 and FR10 groups. Participants in the no training group were compensated $40 for completing the pre- and post-test assessments, while participants in the FR1 and FR10 groups were compensated $100, consisting of $40 for the pre- and post-test assessments and $60 for their training period with a virtual computerized test. Our results showed that no training group became significantly less impulsive when compared to the participants in the FR1 and FR10 groups. This may have been caused by the lower incentive associated with the monetary value of our study. Additionally, participants in the training group only came in at the beginning and end of the 2-week period. This suggests that the physical act of coming into the lab every day for 2 weeks in itself served as a form of reinforcement for the experimental groups. Additionally, while we were looking for other reasons why the control group did not stay the same, we came across that when participants repeat a delayed discounting task without performing any other action in between, they are more likely to provide less impulsive responses the second time. I'm now going to introduce David to talk about our final conclusions.
Thank you, Sheer. So, in conclusion, we can see that certain aspects of our hypothesis are supported by our research. As expected, the fixed ratio 1 group's impulsivity increased relative to control. Interestingly, the fixed ratio 10 group also increased in impulsivity. Now, this group's increase in impulsivity was unexpected as the reinforcement schedule was chosen to model self-control. Another unexpected result was that the control group's impulsivity did not remain the same for the study. But as Sheer just stated in the last slide, this is already been recognized in existing literature. So, our research has shown us that both reinforcement schedules increase impulsivity, which likely indicates that the variance in delays we chose for drug-like and non-drug-like conditions was not large enough to provide a distinction. So, to improve our methods for future research, the difference in delay between schedules would be increased in magnitude. So, for our study, we used FR1 and FR10. For future research, we would suggest FR1 and say FR100. So we can apply this idea to future research with a titrated model. In the titrated model, all groups, including the control, start at an FR50 reinforcement. As the study progresses, the drug-like group titrates to an FR1 schedule, while the non-drug-like groups titrates to an FR100. The control group stays at an FR50 reinforcement schedule for the duration of the study. Now, this model allows us to have all 3 groups obtain the same amount of total compensation, while also increasing the difference in reinforcement delays relative to our current model. So this brings us to the big picture. What does our research mean practically? Well, we've observed that the reinforcement schedule of drug use increases impulsivity. So we can now complete that cycle we posted earlier in the presentation. Not only does impulsivity increase one's likelihood to engage in drug use, but the actual act of administering drugs increases one's impulsivity. So with this vicious cycle confirmed, we must use this knowledge to fuel further research. Research that studies methods of combating not just the pharmacological effects of the drug, but the reinforcement schedule associated with the drug's addictive behaviors. These methods could potentially break the cycle of drug addiction and impulsivity, leading to more effective processes in today's addiction treatment programs, lower relapse rates, and ultimately, less people who have to succumb to addiction. So with that, we'd like to conclude our presentation for you today. We thank you for attending, and we especially like to thank our amazing team for Dr. Richard E. for all of the resources and guidance for the last 3 years, Caper Lab, Gemstone staff, and our thesis discussants, Dr. Neil Ackley, Dr. Donna Chandler, Dr. David Hodder, Dr. Rebecca Hamilton, Dr. Carl Linguist, Dr. Joydeep Srivastava, Ms. Ali Stubby, and our librarian, Ms. Jerry Fowler. And we'll now open the floor for questions.
All right, excellent job, Team ADDICT. Very, very good. Dr. Yee, would you please stand up and give you a big thank you. Okay, now we're going to spend 10 minutes or so with our discussants asking the questions they want to ask first. And I'll ask you first to introduce yourself when you ask the question. And then after that's concluded, we'll move to the general audience asking whatever questions they choose to ask. So who wants to go first? Yes, sir. Yeah. Speaking of the microphone,
So I'm Carl Ledgway. I'm the director of the Center for Addictions, Personality, and Emotion Research on paper here. So I have a personal investment. I'm really excited about the great project that was happening, led by Rich. So my question is, I'm thinking about the Gemstone student, and I'm sure for Gemstone students, whenever you study, you go get it. So put that aside for a second. But for students like I was, when I was a undergraduate, there wasn't necessarily a guarantee that simply because you studied, you get it. So when we think about delay discount, that's one piece of the equation. For the person with drug addiction, there's an immediate benefit, but there's also a guaranteed benefit. For the student, at least for many, there isn't a guarantee also. So when you're thinking about what you'll do in terms of informing treatment, you have this excellent work on delay discounting, but how might you think about what I think people in the literature call probability, or maybe said more simply, the idea that just because you do the right thing doesn't mean it's going to work out. So how can you think about that and thinking about your results and expanding
That's a really good question, and I actually said that's probably something we kind of start discussing questions we may get. So really what it comes down to is our study was not necessarily looking at the methods to combat the processes of addiction, right? We were really trying to understand that relationship. And we got to this point where we found that link, and really our purpose and what we're saying is this warrants further research. So we have been able to show that causal link. We now we extend it to the people that are performing further research on top of us to provide more insight into how to actually apply those processes.
Very good. Let's go to the next question.
So I am Donna Chandler, and I am the director of a division at the National Institute on Drug Abuse that studies epidemiology, prevention, and treatment services. So I look forward to fabulous, long scientific careers in the area of drug abuse and addiction from all of you, because we need, as our institute director says, more brains involved in studying addiction. So when I read your thesis, first of all, great job, lots of hard effort. When I read your thesis, one of the things for me that was missing was anything related to the neurobiology of addiction. And actually the neurobiological mechanisms that we understand that are a part of impulsivity and impulse control. So my first question is, did you think about including that literature? And if you decided not to, what was your reason for not including it? The second question is that when it comes to addiction, we know that there are certain things that are a part of the underlying urge to continue using. And it's also very much related to what we know about impulsivity and impulse control, and that has to do with expectation. The expectation of the reward, the expectation of the reinforcement, and then also there's a key role that memory plays. And those weren't necessarily a component of your experiment, but how would you design your experiment to include those?
Thank you for both those questions, which are very good questions. As to the first one, which regarded the more chemical effects of the drug, we feel that the fact that we excluded it ended up making it a little bit more generalized into the general process of addiction. We feel that some other types of addictions, such as internet addictions or gambling addictions, which don't necessarily involve any substances, might be might have the same process underlying it, which is what we chose to explore here. Certainly, there are other studies, particularly animal models, that use the drugs themselves that might be more informative. One of the other considerations that we wanted to make sure that we had was that we're not human subjects. It's a lot harder to get real drugs in human subjects in our research. We felt that this approach was a little bit easier to execute and perhaps a little bit easier to do. The second question that you asked was about expectations and memory and how that might inform future research, and that gets also a little bit back to the probability discounting, and that may be a result which is more certain when you weight it higher, the result is less certain because it is more certain. And that's not an area that we hit on at all, but we can certainly expand the measures of impulsivity that we use to include some more probability discounting measures. And there is an assessment way of using a different section of the paper where instead of comparing their delay discounting with timing and probability discounting, they have a task where they fill a balloon on the sleeve of money, and the more full it gets, the more likely it is to pop, and then they don't get any money. So it's measuring their impulsivity, how willing they are to push it to the limit and try to get as much as they can, and the more risk averse, not fill out the side and take money variables. One assessment that we can possibly do that.
Okay, let's go on to the next question.
Good afternoon. I enjoyed your presentation. I'm Rebecca Hamilton. I'm at the Smith School of Business. I study human behavior. So the first question I have concerns the setup. So your team set up two different reinforcement schedules. And when I said consumer behavior, I think consumers are going to react to the rewards. So I thought about the incentive that you use, which is monetary. And money is sort of an abstract reward, and rewards were given in the future, not necessarily immediately. So if I could think about how that compared with the substance abuse, about sort of the visceral power reward, and wonder why money was chosen for these reinforcement schedules. Is that because the DET very also uses money? Do you have a bit about that? The second question I had was related to the question we just had about the impulsivity of the so you had some individual measures of impulsivity, different scales, and you did a very nice job in the thesis ruling out in different conditions in a number of variables you measured, including the impulsivity measures. But one thing I was interested in was whether they might interact with the conditions. So there was earlier research that you looked at that suggested that more impulsive people would definitely our reinforcement schedule.
So your first question was as to why we used the money as we were doing our delay discounting test. We had two assessments. The delay discounting test was in a program that could have been noted in different terms, and that program, that assessment, had options also for us to discount things such as cigarette use or other more substance abuse behaviors. We certainly, as you mentioned, in some other literature out there. As far as our groups go, our pre-existing differences in groups on facility measures we didn't really find, and mostly hoping that any subject matter is about higher training design. And three different training options. So we could dissect it a little bit further and allow whether any pre-existing groups to consider for those purposes.
Okay, we're going to open it up to the rest of the room now as well. I think there are plenty of time to discuss their top issues. So if anyone has any questions, we'd like them to come at this time. Yes, sir.
In your presentation, you introduced the term AUC. I hope you understand the meaning of AUC. How would you relate impulsivity and drug addiction to AUC? That's the question. For the sake of the audience, I understand what the meaning is, but many of the folks attending here may not. The second point is that impulsivity is a relative term. If you really need to quantify what kind of neurobiomarkers you may think about doing in the future so that we can quantify the extent of impulsivity.
So as AUC goes as a measure of impulsivity, this is how we used AUC in our measure of dot. AUC stands for area under the curve, where we plotted their indifference points and then unified those together in area under the curve of the curve created by connecting those difference points. So that's just one way that we measure impulsivity. Actually, there's another version that we didn't present here, but that is in our thesis, which is LNK. That's this sort of hyperbolic, and there's some existing research that, in fact, it does look like a hyperbolic model responsible for governing delay discounting. So another measure that we could have chosen is to see exactly what the functions that yields that hyperbola and quantify that. And we quantify that as LNK with some similar results. Your second question was about neurobiology relation. Yeah, that's not an area that we dealt with much in our thesis. Much more basic on our level with our delay discounting. But there could certainly be some more neurobiological research, particularly I think we've seen some studies using functional MRI imaging that might show which areas of the brain are active in impulsivity and decision making and probably not different.
Okay, do we have another question from the audience?
So I'd like to congratulate the students for this wonderful presentation. I'm sure you clearly understand how difficult it is to do research. So I have two short questions. The first one is, how did you choose the sample size? Of course, budget is a consideration, but were there other considerations to lead you to come to the sample size? And the second question is about subgroup analysis. I think that the number of females and males in your study was not equal. And so I'm not sure whether there is any data to suggest differences between males and females in terms of impulsivity and addiction. Were you, despite the small sample size, were you able to do some subgroup analysis in terms of gender?
So our original sample size, we hoped to have a sample size of 135 participants, but we knew that would probably end up being an overestimate. We started running participants based on our availability, and so we were running maybe 6 or 7 participants in a span of over 2 weeks. We ended up having a little bit more than 69 by the end of the conclusion of our study. In terms of women and men, there were significantly more women in our study than there were men, but there were no significant differences between the two genders.
Okay, we have time for one more question, so let's take the last shot. All right, yes, sir.
The phrase you did not use was delayed gratification, which is a term I heard from my studies many years ago. Has that term fallen out of favor or it's still used, how does it relate to any of the terminology you did use?
So basically, when we were talking about delayed discounting, we offered them, the participants offered lower immediate reward versus a higher delayed reward. So, and then that does take into calculate gratification, because in order to take the higher delayed reward, you have to delay the gratification. So, in a sense, it is sort of treated. But delayed discounting is an acronym for the specific protocol, the specific test that we use. So, it does take into calculate gratification.
Okay, very good. I'm going to leave you with one big round of thank you to Team ADDICT. What we're going to do now is ask everyone just to stay in their seat.